Okay guys, so you need to know the difference between specific heat capacity and heat capacity. Heat capacity is also known as thermal capacity. Now heat is basically thermal energy. Capacity, what does capacity mean? مقدار, right? It's like the amount of energy you can store in this object. So how much capacity? So you can use the word capacity for volume as well. So if like I have a cup over here and I have another cup over here, obviously this has more capacity and more room to store a certain volume of something. With heat capacity, you're talking about how much you can store in heat terms instead of physical things that you can see. This is how much heat can be stored in this object. So when I'm trying to talk about how much energy can I store in a certain object, I want to talk about how many joules I can store in a certain object. With the specific heat capacity, the idea is that each material has a certain specific heat capacity because we are controlling one aspect of this whole thing where you're controlling the mass. So mass for the specific heat capacity is always 1 kilogram. We're talking about 1 kilogram of water compared to 1 kilogram of aluminium. It doesn't matter. So basically how much energy is required to heat up 1 kilogram of a certain material by 1 degree Celsius. For water, we know that C of water is 4,200 joules per kilogram Celsius. We know that for C, for aluminium, for example, I can't remember how much it was, but let's say it's 700. Right? So for water, if you are trying to heat up a cup of water, or like a liter of water, so 1 kilogram of water, and you want to heat it up from 15 degrees up to 16 degrees, you need 4,200. With aluminium, you have a block that's 1 kilogram. You want to heat it up from 15 Celsius to 16 Celsius, you're going to need 700 joules. Here you're going to need 40. So that's the idea of specific heat capacity, where it's specific for each object, and you need to determine how much energy you need for each kilogram to raise it by a 1 centigrade. So if you want to talk about how much energy would I need for water if I want to heat it up from 15 to 17 Celsius, then it has to be 4,200 times 2 because it's 2 degrees, right? So it's 8,400 joules. Now, what about heat capacity? Heat capacity, you disregard the mass now. Basically, it's M times C. So, what do I mean by that? How much can I store, or how much energy do I need to heat up something? And that something is not, the mass is not constant anymore. So, say you have a glass of water, a big block of aluminium. So say you have 2 kilograms of aluminium and then you have 0.25 kilograms of water. And then I tell you I want to heat both of them up by 1 degree Celsius. So I want to heat both of them up from 15 Celsius to 16 Celsius. So how much energy do I need to heat each one up? And then you can also calculate how much heat capacity, so how much can you store in this object? Because the more energy you need to heat up something, the more energy it can store. So the bigger the thermal capacity will be. Even though the specific heat capacity of water is higher, if we do the calculations now, so thermal here, capacity for water in this example is 0.25 times 4,200, which is 1,050 joules, right? And this is per 1 Celsius degree change, per 1 Celsius degree change. This is for water. If I want to find the thermal capacity of the aluminium in this example, you need 700 times 2, which is 1,400 joules per Celsius. So that means that even though the specific heat capacity of aluminium was higher, but the thermal capacity of this whole system now is higher. So I need more energy to heat up 2 kilograms of aluminium than I need for a quarter of a kilogram of water by the same change in temperature, right? So it can be seen and understood in multiple ways. But it's basically the amount of energy that you need, but also how much is it storing inside of it. So if I have heated up this 0.25 kilograms of water and I want to extract this energy back, and same with aluminium, the aluminium has a lot of energy, more energy stored inside, and then it will then dissipate it back into the surroundings. Oh my God, you're so annoying. It's gonna give back 1,400 joules for every Celsius drop. So yeah, so basically you need 1,050 joules for this cup of water to heat it up by every Celsius degree change. So now you're basically, the difference between heat capacity and specific heat capacity is that specific heat capacity is always for 1 kilogram. Whereas with the heat capacity, you multiply the C with M. So another thing that I want you to kind of notice is you already know that E equals MC delta T. And now you basically have MC is the thermal heat capacity. So MC is equal to the energy over change in temperature. That's basically what thermal capacity is. So thermal capacity is the mass times the specific heat capacity, which is joules per degree Celsius. But yeah, so basically, even if something has a higher specific heat capacity, but if you have less mass, then you're going to be able to store less energy or less heat in it. Something with a lower specific heat capacity but a higher mass can have more heat capacity. So just to conclude, specific heat capacity is the amount of energy you need to heat up 1 kilogram of a material by 1 Celsius. Heat capacity is the amount of energy stored or required to heat an object up by 1 Celsius. So the only difference is that you don't take into consideration the mass. So you just multiply the mass by C.